Okay, so remember the Unit 3 test is comprehensive or cumulative for the entire semester. So this concept will show up again on the Unit 3 test. The Unit 3 test is worth 60% of your Term 2 grade. Okay? It says the limit as x approaches 3 of the function f has a value of 7. What that's telling you is that if you were thinking of a table, you would say, if my x-coordinate is infinitesimally less than 3, then my y-coordinate will be infinitesimally close or perhaps even equaling 7. Okay? The limit refers to both left and right. So that also means that if my x-coordinate is infinitesimally more than 3, the y-coordinate is really, really close to 7 as well. What you have to make sure you don't make the mistake of thinking is this statement is not telling you anything about what's happening when x is exactly 3. So we're not talking about that. We're only talking about the blue. So now we can look at the questions. It says, is f continuous at x equal 3? You need to remember from Unit 1 the definition of continuity, which says f is continuous So f is continuous at x equal 3 if the limit from the left as x approaches 3 is exactly the same as the value of the function precisely at x equal 3, and that's equal to the limit as x approaches 3 from the right. I haven't done this all year, but let's do it right now. One thing I noticed in Unit 1 is a lot of people didn't really do a very good job of memorizing what they needed to memorize. So in the when we did the retake prep sessions, I made sure everybody had flashcards. Hold on 1 second. So I highly recommend that at certain points in the discussion that you make a flashcard for certain topics. What I found is that with AP Calculus, it just isn't enough to kind of have a sheet to memorize. It's like you need to have certain memories well embedded, and flashcards are actually the best way to do that. So let me get these passed out real quick. While I'm still talking and the video is running. So basically, they're asking, is the function continuous? We have to say, not necessarily, because we know the left-hand limit happens to be 7. We know the right-hand limit happens to be 7. But we don't know the value of the function right at 3. So we cannot declare this function to be continuous. Draw a picture of what it's referring to. So I would make a flashcard that looks just like that purple. What I mean by that is on one side of the card, you should write the first line in purple. On the back side of the card, you should write the second line in purple. The idea being that when you are taking Unit 3 tests, you read something about continuity, this flashcard needs to come to your mind. If this flashcard doesn't come to your mind, it's highly likely you won't be able to answer the question. So anyway, the flashcard would have, again, this on the front, and it would have this in green on the back. The next flashcard you need, it asks, is the function differentiable at x equal 3? Well, first requirement for being differentiable, this is Unit 1 again, is that the function be continuous. So since this function is not continuous, it's therefore not differentiable. As long as we're making flashcards, I would make this flashcard as well. I would write f is differentiable at x equal 3. On the back of the card, I would write f is continuous. That's the first requirement. This is a new, then the second requirement is that the limit as x approaches a from the left of the derivative, f prime, must be exactly the same as the value of the derivative at a. It must be exactly the same as the limit from the right as x approaches a of the derivative. So you need that flashcard as well. So I would make that flashcard now. The third one, it says f of 3 equals 7, same thing. Knowing the limit as x approaches 3 does not tell me anything about what's happening precisely when x equals 3. Therefore, none of these have to be true. So, please, Alice.
Can't it be continuous and have a corner and not be continuous?
So Allison's question was, can a function be continuous like so, have a corner, and therefore be not differentiable? And that's absolutely correct. This function that I've drawn is continuous. Right here at the location of the corner, that function is not differentiable. Two corners. Something that helps me when I think of this right here. Knowing that the limit as x approaches 3 is going to equal 7 is telling me that if I had a graph and I'm getting close to x equal 3, the y value is going to get close to 7 on both sides, but I don't know what's happening in the middle. That's why I don't know whether the function is continuous or differentiable. So, follow-up questions? Please.
Why is it F prime?
So the word differentiable, 2 points for Miles. Miles asked why this definition is referring to F prime, correct? So the word differentiable means I can find the derivative at every single point on the function. So for a function to be differentiable at a point, it means I have to be able to find, it's very similar to continuity. For continuity, I have to be able to find a point right at the spot, a point infinitesimally close on the left, and a point infinitesimally close on the right. What differentiable is referring to is I have to be able to find a slope on the left, a slope on the right, and a slope in the middle that are all the same. Because differentiable means I can find the slope. That's why this definition talks about F prime, and this definition talks about F. Did that help at all? Okay, 2 points. Please, Carl.
So isn't that equation just a horizontal line?
This one?
X equals 7.
So, Carl's question was, isn't this a horizontal line? What you're mixing up is the following. If I had a function that was simply f of x is always 7, that is definitely a horizontal line whose value is 7. This isn't saying that. This is only referring to what's happening to f when you are picking x coordinates that are infinitesimally close to equaling 3. So this isn't talking about the entire function, it's talking about one tiny, tiny spot. Does that make sense? Yeah. Okay, 3 points. Sorry, 2 points. Anybody else? Any other questions coming to mind on this idea? Cool. Anyone else come to class prepared to ask